Next, we'll solve using the quadratic formula. First, we want to have our quadratic equation in standard form, that is, set equal to 0, and then we'll use the formula here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. If it helps you, you can write a, b, and c under each of the numbers. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2 times a. So we have negative 6 plus or minus the square root of 6 squared minus 4 times 3 times c all over 2 times 3. From here, we just need to simplify. Negative 6 plus or minus the square root of 36 plus 4 times 3 times 5 is 60 all over 6. Simplifying more, we get negative 6 plus or minus the square root of 96 all over 6. From here, we will simplify the square root of 96. So think of this as 16 times 6. We want the biggest perfect square that is a factor of 96. We can now rewrite this as negative 6 plus or minus 4 square roots of 6 all over 6. And now look to see if these three numbers have anything in common. They have a factor of 2 in common, so we can factor out a 2, leaving us with negative 3 plus or minus 2 square roots of 6 all over 3. Next, we're going to look at the discriminant. The discriminant is the quantity b squared minus 4ac. That may look familiar to you. That's the radicand of the quadratic formula, the part that's under the radical. If b squared minus 4ac is positive, that means we have two unique real solutions. Two unique real solutions means the graph crosses the x-axis twice. So you have these two x-intercepts, or real solutions. If b squared minus 4ac is less than 0, then we have two unique imaginary solutions. Graphical representation of that is no x-intercepts. Either the graph is completely above the x-axis, or you could have one that is completely below the x-axis. Essentially, it never crosses the x-axis, therefore it doesn't have x-intercepts. The answers are imaginary, or the solutions are imaginary. If the discriminant is equal to 0, then we have one real solution. And graphically, that means we have one x-intercept. So it could look like this, where it's facing up, or it could be facing down, where it has a single x-intercept